Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Mary Lou. Do you need help with your math homework tonight? Well, we have tutors here until 5:30 tonight. Give us a call if you're calling from Bakersfield. You could call us at 636-4357. Or if you're calling us from San Luis Obispo, you could call us toll free at 1-866-636-6284. Or you can email us questions at dothemath@kern.org, or through social media. You can contact us through Facebook, Twitter, all that wonderful things. And remember, you can watch us online at dothemathonline.net.
All right, you know what? We've had a couple of holidays the last couple of days.
Yes, we have.
We had National Pancake Day yesterday. Did you go get any pancakes anywhere? I missed that myself. And right before that was National Trivia Day, and we're going to do a little bit of discussion about that in a couple of moments. We have a very special guest in studio. We'll be going out and about with Devin. We'll be visiting a woodworking establishment. And we also will be taking some phone calls. But before we do any of that, let's first take a look at today's Math in the News. So like I said, the other day was National Trivia Day. Were you aware of this?
No.
I wasn't either until I saw some article come across the internet. I was like, oh, all right, National Trivia Day, great, you know.
There we go.
We'll see what's going on. Of course, I have all these little tidbits about things, and always amusing to read a lot of these little trivia things. So anyway, you familiar with this character?
Yes.
Fond memories of childhood right there?
Well, I have to say, my kids,
You didn't watch this when you were younger?
I did, but I really did a lot with my kids. And
The Count.
The Count.
The Count. All right. Count von Count's love of numbers isn't just a quirky character trait. In traditional vampire folklore, the bloodsuckers have arithmomania, a compulsion to count. So it's not just a folklore. So
there was a reason why he's the Count.
The Count was counting, right? All right. So I figured let's take a look at counting numbers, right? So counting numbers are a set of numbers that we use to learn how to count: 1, 2, 3, 4, 5, etc. Also called natural numbers. Maybe since they feel natural to us because they are naturally the first numbers we learn. Sometimes they're also referred to as positive integers. And I figured let's take this a little step further and get a little more math involved here. We can see here we have the counting numbers, right? The natural numbers and also whole numbers.
Which
and then we can
includes the zero. That's the only difference.
Right. And then we've got integers there. We've got rational numbers, measuring numbers, estimating, irrational numbers, and things like that. Imaginary numbers, all sorts of things. And so I just figured we'd take National Trivia Day with the count, counting numbers, and expand it a little bit so students that have not yet experienced these numbers can kind of see what they are, where they fit in with everything else. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, we have Diego. How are you?
Good.
Everything well?
Yeah.
All right. Why don't you let everybody know where you go to school and what grade you're in?
I go to Castle Elementary, and I am in 6th grade.
So Castle is home of the Knights, correct?
Yes.
And how long have you been at Castle?
Ooh, since kindergarten.
Since kindergarten. So you've been there ever since you've been in school?
Yeah.
What is one thing you think you'll miss because you're going to have to leave Castle next year at the end of 6th grade. What's one thing you think you'll miss after having been there for 7 years?
Well, plentiful, like all the teachers and the staff. I've become very familiar with them, and I will miss them.
There you go. Well, you know what? It's important to build relationships like that, and you'll remember them long after you're gone, and they'll remember you as well. That's why when you get into high school and later on after that, you go back and visit and say hi.
Yeah.
You do that?
Yeah, I hope.
Right. Well, you know what? We're going to put you to work right now, so why don't you head on over to the board.
Come on, Diego.
And this is part of your homework, and I'm going to have Mary Lou write the problem up on top of the board, and then we're going to have you explain it and solve it. All right? So we have 4 is less than or equal to x, which is less than 7.
Okay.
So Diego, there's some students out there that are looking at that going, well, I kind of get part of that, but not all of it. So we need you to kind of explain what's going on.
All right. So first of all, we're gonna ignore the longer part. We're gonna start with the beginning of it, and we see that this sign looks kind of weird. We know this means less than or equal to. So in this case, the number that is given is 4. So what we do is we put a circle above the number 4 on the number line.
So is it just a circle though? Because the line underneath that is something special.
Yes.
What does that mean?
Equal to. So in case if that line ever pops up somewhere, you like fill in the circle.
So that refers to that is less than or equal to, the shaded in. Okay.
That would also be a case if that was just an equal to.
Okay. Okay,
We'll
keep going.
continue?
Is that it? Yeah, continue on.
Okay, and then we see that the sign is saying that that's like less than. So that means the x has to be bigger than. On the number line, the right is always the bigger side, so we write an arrow going this way.
Okay.
Okay, and then we move on to the second part, which says x is smaller than 7. In this case, we would put another circle above the number 7.
Did you want to switch colors?
Oh, yeah,
There you
sure.
go.
We could put a circle above the number 7. And
Now, is this one shaded in, Diego?
no, because there's no equal to, and that's just a regular little triangle.
Okay.
So, and then to continue, this is the x is smaller than the 7, and smaller than means that it goes to the left. So we move an arrow to go to the left. And you can see that they both combine. So the numbers in the middle are the only possibilities for x.
Very good. So this is telling us that 4 is less than or equal to some unknown number, right? Which is less than 7. And so by graphing it, it shows us that 4 is a possibility, right? Because it says or equal to.
Yes.
5 is a possibility, right? Because let's prove it. Is 4 less than or equal to 5, which is less than 7? And then 6, again, is 4 less than or equal to 6, which is less than 7. Yes. What about 7 though? Will 7 work? Can I say
No.
4 is less than or equal to 7, which is less than 7?
No, because it doesn't make sense for a 7 to be less than the 7 if they're the same number.
Right, and that's why this is a what? Open circle. Because that tells us that 7 is not included, right? But it's less than 7. Can decimals also work in this, or is it only these whole numbers?
Oh, absolutely. It could be 6.999. It doesn't matter.
Very good.
As long as it's under 7 and over 4.
Very good. Awesome job, Diego. Good job.
Nice work on that first one. Thought you were going to have Diego there with the only whole numbers work right there, but he was on top of that thing. Hey, we do have phone tutors available until 5:30 this afternoon. Right now, we're going to go out and about, see what's going on with Devin.
Hey, thanks a lot, Mike. Mary Lou back in the studio. We're here live at Ames Woodworks and Violins, joined by owner Sam Ames today. We're going to take a look at how math applies to another one of the fine crafts of woodworking. So, Sam, first of all, thank you so much for having us in the shop today.
Thanks for coming. I love sharing.
This is our second year here with our shop, and for those of our viewers that might be joining us for the first time, tell us a little bit about Ames Woodworks and Violins.
So I started doing string instrument repair, violin family work about 15 years ago, and been doing that for quite a long time, do a lot of work for the Panama District and players around town, symphony players. And I started tinkering into some woodworking endeavors a few years ago, and really enjoyed working with rustic reclaimed material there. So the violin studio has kind of been overrun with some woodworking tools and other items, and doing a little bit of that now as well.
That's kind of the sign of growth, is when you start off with one specialty and you end up doing everything else in the process.
Yeah, for sure.
Well, if you don't mind, go ahead and give us a tour of the shop. Let's take a look at what we have to work with.
So it's fairly intimate. It's my grandiose 400 square feet, but as I kind of work the way around the walls, I've just got stations where I do things. I do some tool sharpening here at the sink, because I use all the Japanese whetstones for that sort of thing. Templates and trinkets for some other projects on this shelf. Drill press, of course. Clamps, various wood items of all kinds of shapes and sizes. Templates for projects that I've done before. Pizza peels.
There we go.
Yeah, done some pizza peel work
Phenomenal.
there. So these are some blanks that are still waiting to be done out of some nice walnut, and going to cut those up this Friday, as a matter of fact. So yeah, I keep some of the storage in here. A lot of the instruments that wrap around as we go are usually bygones from repair work, previous tinkering things and making sure I know how to finish a certain repair a certain way. So they're kind of my Frankensteins that I keep out here in the shop. And I keep all the good stuff in the house. So
when a lot of our viewers, kids think of woodwork, they think of saws, and generally there's only a couple of different types of saws that they may be aware of. So what are the kinds of equipment do we have to be able to shape and mold and
Sure. So the staple of any workshop is, of course, the table saw. And this particular table saw that's made by SawStop is really kind of a cool saw. It has a unique feature on the inside that every parent would want their child to have if they were to work on woodworking items. It has an electronic eye sensor on the inside. So if the saw is running and your finger should unfortunately get too close to the blade, it pulls and retracts the blade in a nanosecond down inside the saw.
Oh, wow.
So it's a really good safety feature. So we paid a lot of money for it, but it's worth its weight for sure to not lose a finger.
So that's going to allow you to manipulate and cut through all kinds of different wood sizes, boards, or some of the flat panels that you might see.
Absolutely. Well, gets used every day and very, very often.
Now, one of the things we talked about is a lot of the work you do with metal workers or fabricators to help build the frames for some of the pieces that you put together. And there's an example of one that you've been working on here, a chair model?
Yeah, absolutely. So this week we're doing some commission work for a customer, and this particular item was a chair frame. So this is our frame here. So it's all been welded and powder coated and cleaned up. And then this is going to be the seat back, and then the seat flat will be made tomorrow.
Now, for those of you wondering at home, the sides of that, I'm sure, do not look very comfortable as just a set template. You know, one of the things we talked about is the idea that if you have a design in mind, you may measure things right, you may have an idea of what that's going to look like, but it's still going to take a few different prototypes or tries before you get it just right.
Absolutely. The chair has gone through multiple revisions to really get it comfortable and to get it to where it needs to be. And as you mentioned, yeah, there's still a lot of shaping and glue that has to be removed and cleaning up and rounding and softening to kind of get to that point. And lots of revisions. I think we went through about 10 revisions before we finally determined, okay, this is the one that we really enjoy.
You mentioned some of your work with the symphony orchestra, and specifically working with violins. Take us through kind of some of the work that you might do with the standard model.
Yeah, so I've got a few things in various stages over here. So this was a violin that we had to remove the top on. So this is a violin top when it is off the instrument. This is a very inexpensive instrument where it was kind of hastily carved, but if they want to pay for the repair, we'll get the work done. So this top was similar to this. It was off, glued and repaired on the inside, and now it's been glued back together.
Now, in the world of violins, a little change can make a big difference in the sound. So what are the things that you have to take into consideration in getting the sound of the violin just right for the client?
So one of the biggest things that we really look at with an instrument is when a violin or a viola or a cello or any string instrument, ultimately any instrument is made, it really develops its own voice in the carving and the making process. How thick or thin what we call the plates, so the tops and the backs and the sides. Every instrument's going to have its inherent voice. Beyond that, it's really the setup, how well the bridge is made, which is the piece that goes here, what type of string we're going to use, are we looking for a louder sound, a softer sound. So we just try to complement what the maker has done with the instrument, if it's an individual single maker, and if it's more of a mass-produced, then we really emphasize making the setup proper so that it plays well.
You know, a little bit outside too. We mentioned the prototype design for this piece here. There is a bit more of a finished model out here that we can kind of look at. And you can kind of walk us through the approach and the idea behind it. So this is a bit more in line with where ultimately something like this will end up.
Yeah, so this got worked on a little bit this morning. So we were able to cut and trim off all of the excess, get the glue lines planed down. Still needs quite a bit of sanding. This particular chair, different than the one inside, is what we call a captain's chair. So it has arm rests on the side, whereas that one will just be a side chair and open seating. So this is kind of when we start to get to the point where we're removing the excess material, doing some math to determine our final lengths and widths, and what kind of round edge we're going to put on it.
So a little bit later on in the program, we're going to come back to Sam. He's going to walk us through some tips on making sure that we can use math to find the right size board of wood for the right project. But for now, we're going to send it back to the studio. Mike, Mary Lou, take it away.
All right, thanks for that, Devin, and also thanks to Sam out there as well. We have phone tutors available until 5:30. In studio, we've got Diego. Time to work on another inequality. So back to the board with you, young man. Here we go. Now we have 4 is greater than x, which is greater than or equal to -2.
All right, Diego, take it away.
All right, so we begin again. We ignore the second half. We see this first half, the number that is given is a 4. Circle above the 4. And since this does not have an equal to, or it's not an equal to in any shape or form, we do not fill in the circle. And then we notice that the x is smaller than 4. And since it's smaller than 4, smaller than on the number line is on the left. So we move the line to, well, all the way to the left.
Okay.
And if we can continue, the x is greater than or equal to -2. So we put a circle above the 2. And since that says equal to, we can fill it in. And now we see it says that the x can be greater than, and greater than on the number line is going to the right. So if we go to the right, that would explain. So these numbers in the middle are all our possibilities.
Okay, so last time I was the one who kind of went through and proved each one. So this time, Diego, I want you to prove each one to us.
So if we begin with -1, we can see that 4 is definitely bigger than a negative number. And then -1 is actually bigger than -2 because it's not so much in a negative.
Okay.
And 0, 4 is definitely bigger than 0. And -2 is smaller than 0. It goes below 0. Well, yeah, you can see there. And continuing, these numbers are also the same in 2. Like 4 is bigger than 2. 2 is bigger, or well, yeah, bigger than -2. So, continue on for the rest of the numbers.
Okay, and let's do 4 again.
Yeah, 4 wouldn't work because 4 is not less than 4, it's the same as 4.
Yes, and that's why, again, we have the open circle, right? And then here you skip the -2, but that's equal to, that will work, right?
-2 is smaller than 4, and -2 is the same as 2, so it's fine.
Well, I think you have this down. I think we need something else, Mike.
There you go, nicely done. Well, erase the board, get rid of the number line, we'll move it on.
Okay.
All right, hot shot, here we go.
Ready?
4, open parentheses, c plus 3,
C plus 3.
close parentheses, minus, open parentheses, c minus 1, close parentheses, is equal to 64.
All right, Diego, you ready to tackle this?
Yes.
Okay, tell us what we're going to do.
So we're going to do this parentheses first. So 4 times c is 4c. And the 4 times 3 is 12. And since those are positive, you put plus. And now this is a negative, but...
Fix that. Keep going. I'm just going to fix your C a little bit more. There you go. Keep going.
And there's a negative there, but there's no number. But what I know, in that blank space, we can put a 1. So then we could say -1 times c would be negative c. And -1 times -1 is positive 1, because a negative times a negative is a positive. And now it's equal to 64. We bring it down. And now we move on to doing taking away the numbers. So right here we see there's a 12, and there's an addition, so we can subtract 12 on each side. So we are left with 4c,
Minus C
minus c
plus 1.
plus 1 equals 52.
Okay, I'm going to scroll this up so we have a little bit more room. Now, I'm going to ask you a question because you're obviously going to get rid of this 1, right?
But we also want to combine these two. So combining 4c minus c, it would be 3c. We can bring, we can bring everything down.
Okay, I'm going to go because you're doing an excellent job, Diego. But I'm going to ask you another question. When you did this 12, you got rid of the 12. Could you have combined 12 plus 1 and then kind of taken that all together? Is that just another way to do it?
Yeah, in this, we could have combined the like terms. So it would have been, we would have subtracted the c from the 4, and then we would have added the 1 to the 12. So it would have been 3c plus 13.
Yeah.
But I went the other way.
And that's okay, huh? Both ways are correct. Okay, I'm going to let you continue.
So here's a positive 1. We want to do the opposite. Take away a 1 there, take away a 1 here. We are left with 3c equals 51. So, and finally, since we have 3 c's, but we want to know what 1 c is, we divide this side by 3 and this side by 3.
And you could do your work right here if you need to.
Yes, so I can put c equals 51 divided into 3. So 3 goes into 5 one time, minus 3, 2, 1, 3 goes into 21 7 times, minus 21 equals a happy 0.
There you go. So what's our answer?
17.
Now, do you want us to check it?
You know what? The way he went through that, and we
was
can check
beautiful.
it in just a moment, but I think he did a lovely job right
I
there.
do too.
And Diego is on top of that right
Yes,
there.
he is. And I think, Diego, you need to come to my class and teach my students because you did such an awesome job. Good job.
And for doing a wonderful job, we're going to be sending you to a Bakersfield Condors hockey game. So congratulations on that. Hopefully you have an opportunity to go see the Condors and see a little hockey. All right. Hey, we have phone tutors available until 5:30. We'll be back with more right after this. Today we're in San Luis Obispo County. We're at Shandon Elementary School, and today we're here to... Well, today we're at Shandon School, and I've got 5th grade student Kelly with me. You ready to go? All right, let's take a look at what we've got here. We've got $390 it costs for 1 year to, what do you think it would cost $390 a year to do? Do you go swimming a lot?
No.
All right, well, let's say you wanted to go swimming and you found this really cool pool, and they've got a high dive and everything like that, Olympic-sized swimming pool, and they're going to charge you $390 a year to go to the pool.
Okay.
And we want to know how much will you have to pay every month in order to satisfy that. So how do you think you're going to solve this?
How much per month?
That's what you have to figure out.
What do you do?
Well, we know we have to pay $390 for the whole year. And we're going to make a monthly payment. So how many months are in 1 year?
12.
12 months, right?
Okay.
So what do you think we have to do to figure out how much we have to pay for 1 month?
Divide.
Divide. All right? So let's go 390. And we're going to divide that by how many months there are, right?
Okay.
So now talk me through the problem. How are we going to solve this?
You see how much times 12 goes into 39?
Right.
Because 12 doesn't go into 3.
Perfect.
And
So how many times do you think 12 goes into 39?
3 times?
And what is 3 times 12?
36.
36, right? Because 4 times it would be too high, right? All right, so let's go ahead and where does the 3 go?
Here.
Nice, okay. So we'll put the 36.
12 doesn't go into 3, so you have to drop the 0.
Okay. And do we need the 0 in the front necessarily?
No.
Okay, so let's just leave it as 30. And then now what do we do?
You see how much times 12 goes into 30?
And how many times will that happen?
2.
Okay.
You have to carry.
Okay. So, think about the question now. You owe $390 to go all year. And you're going to pay it over 12 months.
Okay.
So you're going to be paying money.
Okay.
Okay, so how much money are you going to pay every month?
$32.
But you have something left over, right?
Okay.
And what's that?
6.
So do you pay 32.6? That doesn't make sense, does it? No, okay. So you did this correct by saying that there was a remainder 6, but if we're dealing with money, what we're going to do is we're going to add a decimal point and bring down another 0. All right? So what we're going to do is we're going to add another 0 and bring that down.
Okay, so 60.
Right, so go ahead and make that 60. And now, how many times will 12 go into 60, do you think?
5.
That's pretty fast. What's 12 times 5?
60.
All right, so where's the 5 go?
Right here.
Okay. And then put your 60. And do we have anything left over now?
No.
Okay. So now, think about, you're thinking about money. Okay. If you owe $390 for the year, and every month you make a payment, how much money are you going to give them every month?
$32.05.
That's what it looks like, kind of, right? But how would we write 5 cents if we were doing money? Right? If I had $32,
Like that, yeah.
like that, right? That's 5 cents. But is that what we have? No. So what do we need to do in order to make that money? How many numbers are after the decimal point all the time in money?
2.
2. So what do you need to put?
Put a 0.
Exactly. So now, what is the cost going to be every month?
$32.50.
Does that now sound reasonable? How do you know that that is right? Is there a way that you could check that? What would you do?
You times this by this.
Right. And that's all you had to do. Kelly, nicely done. And a big thanks to the students at Shandon Elementary School. And if you phone in from San Luis Obispo County, that number is 1-866-636-6284. We do your math problem. You'll automatically receive ice cream from Doc Bernstein's Ice Cream Lab. We've got Diego in studio. Hooray for ice cream every day right there. You ready, young man?
Yep.
Do you have a favorite flavor of ice cream? Do you like ice cream?
Yeah, I'd say probably rainbow sherbet.
Oh, there you go. All
that's
right.
a
Well,
good
head on over to the
one.
board. We're going to have you do another problem right now. Completely different from what you were working on. We're going to throw some words at you now, okay? But you're still going to be doing some math. So let's take a look at it together. A painter charges $225 for materials and $35 per hour for labor. The total cost of painting an office is $330. So the total cost is $330. The question is, how many hours did it take the painter to paint the office?
All right, here we go. We have $225 for his materials, okay? He charges $35 per hour, is that correct?
Correct.
Charges $35 per hour. This is how much the total cost was for the job, $330, okay? How many hours did he work? Diego, how could we set this up into an equation?
I would say 200 and,
That's okay. There you go.
225 plus 35.
Okay, yeah. 35.
Plus,
Oh, no, you have the right. It's plus 35, but 35 what? Because what are we trying to find out? What's our objective of the question?
Hours.
Hours.
I'm gonna say plus maybe 35x.
You got it. 35x what?
Equals 330.
Right. You know, a lot of times these word problems get students kind of confused, but honestly, if you write it as you read it, it's right in that order. Do you see that? Because we know that he has 225 in materials. In addition, he charges 35 per hour, and his total, and the word total means equals 330, right?
Yes.
And so again, our objective is how many hours? So there you go. Tell us how to solve that now.
Now it's just a simple little problem. Like I didn't do last time. There's no like terms to add this time. So what we are gonna do is do subtract 225 from this side and subtract 225 from this side, and we're left with 35x equals 105. And then we want 1x, so we divided this side by 35. And we divide this side by 35.
And if you need to do your long division, you could do it here in the middle.
All right. So 105 divided by 35. All right, 35 goes into 105.
Well, let's think estimate. Let's look at the 3 and the 10. 3 goes into 10 how many times?
3.
There you go. Let's start there. See if that works.
You want me to like?
Yeah, no, the 3 is over the 5, you're right. But what we're doing is we're kind of using estimation to help us get there. Do you see what I'm doing?
Yes. So I'm gonna do that on
Right.
the bottom.
Multiply 3 times 35.
3 times.
Yep, because you have 3 and 35.
Well, that's fine.
That's okay, if you can read it.
All right. That's 15, 1, 3, 9, 10. Perfect.
Does it work out? Okay.
Well, my handwriting doesn't.
Yeah, that's okay. My writing looks like that sometimes. So what is our answer? How much per hour does he charge?
$35 per hour.
No, he doesn't charge $35.
Yeah,
Well, he charges
Well, per hour,
35.
sorry. How many total hours? That's my mistake.
he worked 3 hours.
He worked 3 hours. There you go. So he worked 3 hours. Awesome job. All right,
Nicely
is that
done,
it?
Diego. Hey, we do have phone tutors available until 5:30. Right now, we're going to go out and about with Devin once again to visit Sam Ames. And I do believe that those guys are getting a special project ready because I know he was working on a chair, and I think they're getting the measurements for all of that. And now I believe they are ready. So, Devin and Sam, take it away.
Thank you very much to Mike and Mary Lou back here at Ames Woodworks and Violins with Sam Ames. So we were looking at some of the pieces here, and we had an interesting kind of revelation. We were looking at these two pieces of board, and we wanted to know exactly how much bigger one was than the other, because comparison-wise, they look fairly similar and almost deceptively. So what Sam and I were talking a little bit about is how we measure the material in woodworking, and we use a unit called board feet. Can you tell us a little bit about board feet, Sam?
Right. So board feet in the kind of lumber world is the length of the board in feet or inches, the width of the board in inches, and then the thickness. And so those are multiplied, and we'll get to that. And that helps us to determine how many board feet are in a particular board.
In a way, if you think about it, we're essentially taking the volume of the board,
Correct.
the amount of space that it takes up, and then condensing that into a unit of feet that we could compare, so that no matter what the shape is or the dimensions, we can put a tangible number as far as how much wood is in a piece. And we were looking at some calculations of that as far as how it aligns with some of the designs you've done. And a lot of the designs you do are on a field that is very familiar to a lot of our viewers, and it's just simple graph paper.
Sure. So oftentimes when I'm working on a project, whether it be a dining table or whatever the piece might be, I always like to chart it out to determine what my costs are going to be. It's a way that I need to give a customer a price for a particular job, but I also need to make sure that I'm not overspending or underbuying the material that's needed. So I generally plot this out, and all of these measurements that you see here, the thicknesses, are all different pieces. This is a particularly table piece that I'm going to be working on. So we've got the top at 8 feet long and 45 inches wide. Tabletops require an apron or a runner. And so all of these items are put together, and then that helps me determine how much material I'm going to need for the project.
So in the example for calculating board feet that you mentioned, you'd calculate the length in feet, and you multiply that by the width in inches and then the thickness in inches. And you can multiply these in any order you wish because of what we know about multiplication. Now, after you do all that, you can divide it by 12, and that will get you the amount of board feet. So in this example that you had sketched out for us, we have a board that's 8 feet long, about 3/4 of an inch thick, and then 10 inches wide to get us to a value of 60, which then we divide by 12 because there's 12 inches in a foot to get to 5 board feet.
Correct.
Now, one of the things that I had questioned is, since we have 2 different units, is it possible to do this in inches instead of feet for the length? And you said yes, but you do need to change something in the division.
Right. So if we were to calculate this out in inches, then we would need to divide by 144.
So because you're multiplying by 12 up here, you need to divide by another 12 down here to get to the same board feet of 5.
Correct.
So what we did was we took this calculation and we actually applied that to the 2 boards that we have over here off to the side.
Sure.
And we measured this out while we were away at break and started to calculate some of the board measurements on this. So just to kind of take a look at some of the calculations, we've measured this larger one.
Right. So this board, when I purchased, was indicated that it was 4 board feet. So we want to make sure we're getting our value for our money, and so we're measuring the board out. And let's get our length. So it's roughly 97.5 inches, but from experience, I know that the industry is going to call this an 8-foot board.
Now, just for the sake of comparison, we have our shorter one, our skinnier one here. I'll say skinnier. It's got lower width. What is the length of this one here?
This one's going to come out to about 101 inches.
Okay, so it's about 5 feet longer or so, maybe.
About 5 inches or so.
So 5 feet. Units matter. Vocabulary matters, ladies and gentlemen. So yeah.
And then on our width, we know that this one is 6 inches. We've actually already written it here. And here, this is going to be called 4 inches. So it really comes out to about 3 5/8. But anything over the 1/2 an inch, the industry rounds it up to the next highest number. So we know that that's going to be 4 inches, and 8, and a 1 inch on the thickness. Now the thickness, this is what we refer to as a 4/4 board. So it's just under a 1 inch on the thickness, but it's not quite 3/4. So in round numbers again, that's going to be called a 1 for the purpose of this.
And so if both of these are an inch thick, this gives you some numbers that now you can multiply out. So we had 8 times 6 times 1. And the nice thing about a thickness of 1 is you can basically just scratch that out. That's one less number you have to multiply by.
Sure.
You'll still do it technically, but we all know what happens when we multiply by 1. So it becomes very friendly. We have 8 times 6, which is 48.
Yep.
And then we divide that by 12 to get to 4. So this truly is a 4 board foot length of wood here.
Correct.
Now, if we apply that same logic over here, we have a board that's 8 feet long times 4 inches wide, so we're at 32 there. But then, again, multiplying by 1, so 32, we have to divide 32 by 12, and that ends up being a little more than 2 board feet. So, I mean, as a buyer, if you see that, we're told that this is 2 board feet, and this is 4 board feet, we have some information that tells us a little bit otherwise.
But it sounds like we got a better deal on this board than we really should have. So there's the bonus.
Whoever we're buying from, keep it up. This is great. But that's important if you're buying materials to know exactly how much of a unit you're actually getting, because then cost comes into play.
It's our number one cost in the work when we're doing woodworking and that sort of thing. So when you look at units of other items like ounces of glue or a number of screws or bolts or other things, they're tangible items that you can physically count. Wood purchases and wood material is always kind of intimidating for people. And when they go to a box store or someplace where they really don't sell boards and board feet and they sell it by the board or by the linear foot, which is another conversation, you really don't know how much they need. And so if you understand how to do some of this and you know what the measurements are in your project, you'll be way ahead on making sure you get the right amount of material.
So this looks really interesting. We're going to come back a little bit later on and talk to Sam about how to get started in woodworking, some of the classes you may want to consider taking, and some of the things you can do right now to prepare for a hobby or career in woodworking. But for now, we'll send it back to the studio. Mike and Mary Lou, take it away.
All right, thanks for that, Devin. A lot of fantastic items that Sam has made over the years, and I know that Mary Lou, you had an opportunity to visit Ames Woodworking last year, and some of the things that he's able to produce out there.
It's incredible. His work is beautiful.
Indeed it is. Hey, we do have phone tutors available until 5:30 this afternoon. We've got Diego in studio, and you know what? I think you've rested long enough, young man. You ready?
Yep.
Back to the board with you. Let's take a look at another problem right here. Jennifer buys a smartphone with a case for $200. So the phone plus the case is equal to $200. The smartphone costs $180 more than the case.
So
the phone is $100.80 more than the case.
more than in the case.
Right.
Equals 180, yes?
Yes.
So we need to know what the cost of the case is.
So we have to find C.
All right.
So what we really need to do here is we actually are going to combine these, okay? So what we're doing is we're going to put a plus sign here. Think of them as numbers, okay? So we're just going to add up the columns. I have P plus P. We're combining we're combining like terms. But what is C minus C?
So, oh, that's nothing.
That's nothing.
That's why you put the equal.
That's why I put the equal sign, because that cancels out. So what's 200 plus 180?
That's 380.
That's 380. Now you finish it for me.
Oh, all right. So now that we have 2P, 380, you just need to divide this side by 2, and then we divide this side by 2. So that would equal P equals, that would,
Cut that in half.
okay, 150, 60.
Okay, we know that this is 1, right? I'm going to do some short division real quick. 2 goes into 3 one time, right?
Yes.
With 1 left over. 2 goes into 18 how many times?
18, 9.
And 0. 190.
Okay, so, okay. Equals 190. Oh. What equals 190?
Now, Mike, what are we trying to find
The cost of the case.
cost of the case? So we know what the phone is. Our phone costs us $190, but we have to find the cost of the case.
So if the phone cost $190 and it cost 180 more than the case, I find that it would be 190 minus
Trying to find C.
180.
And how much is the case going to be?
$10.
$10, exactly. Because if we look at here, again, we know it's 10, and also here, we could go this way. If we know our total cost is 200, right? And we're taking away that 190, we get $10. There you go.
There you go. Nicely done, because one of our camera operators is screaming like, why wouldn't it be 20? Well, you know what, let's address this for a moment.
Okay.
Imagine the case is $20. All right, so put 20 up there.
Okay.
All right.
And let's put 20 someplace. Just write $20.
We know that P is 190.
Okay, 20.
So the phone is 180 more than the case. So add $180 to that. What do you get now?
We get 200, right?
Right.
Yeah.
And that's for the phone alone.
That's just, yes.
Right? So hopefully that makes sense. And do you kind of see it now right there? All right, very good. So we want to make sure everybody's happy with the way this worked out. 636-4357 is the phone number. We'll be back with more right after this. Today we're in San Luis Obispo County. We're at Shandon Elementary School, and today we're here to... Today we're at Shandon School, and I've got 4th grade student Cristobal with me. How are you today?
Good, and you?
I'm wonderful. You ready to go?
Yes.
All right, let's turn around. Why don't you go ahead and grab a marker of your choice right there, whatever color you like, and we're going to go ahead and solve this problem, all right? So we have, let's see, there's 1, 2, 3, 4 different types of fruit and vegetables. So why don't you name me off a fruit or a vegetable?
Watermelon.
Watermelon. I'm just going to go melon, all right? And another one?
Apple.
Apple. What else?
Strawberry.
All right. And you've got one more.
Raspberry.
All right. So there are going to be amounts that we pay for each of these. All right. So we've got $15.50 for the watermelon. All right. What do you think the apples are going to cost? Why don't you give me a number?
$12.
$12? $12 even? All right. I will go ahead and make the strawberries, let's go, they're going to be very expensive because they're out of season right now. And we're going to buy a lot of them. We're going to give them out to people. So we're going to say that those are $33.75. And the raspberries, how much do you think we ought to pay for those?
$10.
$10? Keeping it nice and even. All right. So what I'd like you to do, first of all, Cristobal, is add up how much we had to spend on all of those different items. Now, before we go on, where did you get the 5 from?
5 plus 0 equals 5.
Right, so all we had was zeros and a 5, right? So now where did we get to 3?
5 plus 7.
Okay, so 5 plus 7. Think about that one again. What's 7 plus 5?
12.
12. So what do we need to do here?
Erase it.
There you go, put the 2. And then you carried the 1, right? So now what are we going to do?
Add 5 plus 2 plus 3 equals 10 plus 1 equals 11.
Perfect. Didn't forget about that 1.
And then 1 plus 1 plus 1 plus 3 plus 1 equals 7.
Good. And we'll bring our decimal point straight down. So how much money did we spend on all of these items?
$71.25.
Right. But what we're going to do is I'm going to pay the person with a $100 bill. All right? So if I pay them with a $100 bill and it costs me this, I want to know how much money should I receive. How do we figure that out?
Subtract it.
All right, go ahead and subtract it. So now what do we do, right? Because you can't go 0 minus 5, and you can't go 0 minus 2, and you can't borrow anything there. So what do we need to do here?
Subtract 0 plus 0 minus 1. Oh no, you need to borrow.
There you go. Good. All right, so that becomes good. Now you've got it. So now let's go ahead and subtract. So tell me the numbers you're subtracting.
0 minus 5 equals 5.
Well, you went 10 minus 5, right? There you go.
10 minus 5 equals 5.
Okay.
And 9 minus 2 equals 7.
Good. That's
9 minus 1 equals 8.
Okay.
9 minus 7 equals 2.
So what is the answer?
$28.75.
How do I know that that's $28.75 instead of just 28.75? What else do we need to add to that to make it look like money? There you go. Nicely done, Cristobal. We do have phone tutors available until 5:30. Diego, we're going to put you on the clock. Over to the board, you two. Here we go. We're going to take a look at the problem together. This is the next one in line, right after the one we did, the one about painting. 3 toy cars and 4 toy trains cost $18. 2 toy cars and 3 toy trains cost $13. What is the price of 1 car and the price of 1 train if both prices are whole numbers in dollars?
Okay, you ready? We're going to make a chart. Easiest thing to do, all right? So we're going to take, if we make our chart, all right, and we're going to break this chart into 3s, and we're going to start with our cars, and then our trains, and this is our total. Okay?
Okay,
So what I want you to do is, right here, let's start with the smallest. So here, put 2 cars for me, okay? Put a 2.
Right here?
And then put 3 underneath there, because we have 3 trains. And what's how much our total cost?
It's good. That's 13.
13, very good. Then we have 3 cars and 4 trains, so in the next column.
So we put 3 here and a 4 here.
And what's our total cost?
That's 18.
Now, Diego, what I want you to notice is, do we have a pattern here that goes 2, 3?
Yeah, it goes plus 1.
Yes, plus 1, and does it go plus 1 here?
Yes.
But what's the pattern for the total?
That's a 5 difference.
It's 5 difference, so it's adding 5, right?
Hey, you got about a minute.
Oh, we're adding 5. So we're going to do this. I'm going to go to 1, 2. What's 13 minus 5?
That's
okay. Then I'm going to go 1, 0, 1. What's 8 minus 5?
3.
So that tells me 1 train cost
$3, and 1 car is $8.
No. The train is $3, right? So if we know that 1 train is $3, what's 3 times 2?
6.
6. So therefore, what's the difference between 6 and 8?
2.
2. So 1 car is
$6.
$2.
Oh.
Watch. We have 2 times 1 is 2, right? 2 times 3 is 6. And does that equal 8? Yes. Okay, so real quick, what's 3 times 2?
6.
Okay. What's 4 times 3?
12.
And what's 6 plus 12?
18.
Yes.
Therefore, you know that it works.
Mind blown.
Making a table, a nice easy way to see that and visualize the whole thing. Do remember we have phone tutors available until 5:30. We're going to go out one more time, visit with Devin. He's hanging out with Sam Ames at Ames Woodworking.
Thanks a lot, Mike and Mary Lou. Back here live at Ames Woodworks and Violins with Sam Ames. We had a chance to talk a little bit about some of the pieces in the shop, and someone here had the question about some of the older pieces that you've had a chance to work with, and you were able to pull one literally right off the wall, and we were talking about this violin over here.
Yeah, so I've got the 2 endeavors, and one of my very first loves, of course, is all the violin work I get to do. But this particular instrument just came to me recently, belongs to a family friend, and it's going to be going to Los Angeles to a very reputable and high-end violin shop for an appraisal. But we were curious as to what was the oldest instrument I have in here, and so this violin's from 1730.
This is an artifact that is nearly 300 years old.
Yeah, it's fascinating, and I look at some of the repairs that have been done to it literally over the centuries, and some of it very handsome, a lot of really, really quality repair work. But yeah, German maker, Klotz is the last name, and kind of a fun thing to share.
And one of the things you remarked on that we kind of shared is the idea that the general design of the violin has changed very little in all those centuries. It's almost identical to something you would see produced today.
It's really kind of considered, there are different opinions about it, but the old design is the modern design, and if it ain't broke, don't fix it. So obviously some very, very good current makers and people that are doing a lot of work, but all of it really still based on a lot of the same patterns that were created by Stradivarius and other Italian makers and German makers and people back in the 1700s.
For some of our viewers at home that may have been watching this afternoon and are curious about how to get started in woodworking as a craft, what would you recommend?
So I took probably a little more of an untraditional path. When I first got into the violin world, I was studying largely on my own. Went to a lot of workshops and seminars as an adult. There really was kind of that window for me it had passed for me to go to violin making school, and there is actually a violin making school. There's a couple of them in the U.S. One of them is in Utah, and very, very well known and very, very good. So I did kind of the private path of looking, studying, working, dealing with some people that already had some hands-on experience. In the woodworking world, kind of the same path, but for students and people that are looking to get into it, there are lots of college programs and woodworking trade schools that you can go to, and working it as an apprentice in a wood shop or a cabinet maker shop, and getting some of that hands-on experience and doing some tinkering of your own is really a great way to do it. And as for an adult, for somebody like myself that picks it up as a hobby, if you can find some places where you can get hands-on experience with somebody else that already has that, it's invaluable.
As far as the type of math that you would recommend for students to really jump into and explore to be prepared for this, that would benefit them, what would you recommend?
So geometry is really incredibly valuable. We do a lot of basic math, as you saw, a lot of adding and subtracting, a little bit of multiplying and dividing. But there's so much geometry that goes into in all the different things when you get into angles and how components of a particular workpiece, whether it's the violin world or the woodworking world, is going to come together. So really sticking with those basics and understanding them thoroughly. I look back on my time with math and not wanting to be the best math student, but I couldn't live without it every day now. And whether it's advanced or it's basic, you will use it every day of your life.
Well, Sam, it's been great. We were here last year with the show, and a repeat visit, which puts you in very rare air with a rare company, and that is a two-time owner of our Do the Math Thank You tile. Excellent. As a supporter of the program.
Thank
again,
you.
Sam, thank you for inviting us into the shop this afternoon. Wonderful look behind the curtain of how these things come together.
Well, it's been my pleasure, and I hope you guys will keep coming out, because by the time I get done collecting these, I'll be able to make a trivet or something out of the tiles. So I'm hoping to be a multi-year recipient.
Sam, again, thank you so much for joining us this afternoon.
My pleasure.
Right now, we'll send it back to the studio for the last time today. Mike and Mary Lou.
All right, thanks for that, Devin, and also thank you to Sam for accommodating and having us out there, because I know there's a lot of math that Sam works on, and I just think it's important for the students to see that in something with woodworking and things like that. A reminder, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. Thank you once again to Diego for coming in. Did you have fun?
Yes.
Now we know that you said you were going to miss your relationships with your teachers when you leave Castle. What do you think you're going to be looking forward to most at junior high?
Well, of course, meeting the new staff, and I guess I would also want to get to know learn more about each subject, because now I have a period for each.
No, there you go, right, because you're going to be seeing a lot of different teachers, a lot of new staff. So your circle of friends is going to grow and expand next year, so more to look forward to. Hey, you know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Tracy. And you can reach us in Bakersfield at 636-4357. In San Luis Obispo, toll free at 1-866-636-6284. You can email us, dothemath@kern.org. Watch us online at dothemathonline.net. And don't forget social media, Facebook, Instagram, Twitter, and YouTube.
All right, well, you know what? Today is Wednesday, and we have 1 week left of live broadcasting for this school year. So keep track of that. So next week, the 13th and 14th, will be the 2 final days for live broadcasts for Do the Math. Hey, you know what? We will be going out to the Boys and Girls Club today, finding out some things that are going on over at the club on Niles, the main club for Kern County. Actually, Kern County has the largest Boys and Girls Club in the nation.
Wow.
The number of students that they service and provide services for, Kern County, largest one in the nation. We also have a couple of very special guests in studio, and we'll get to your phone calls, but before we do any of that, let's first take a look at today's Math in the News. All right, well, today's Math in the News, by coincidence, one of our guests coming on today had a birthday last week, and we'll be talking with her in just a few moments. But let's go ahead and take a look at the screen right here. We have various birthday cakes. And you were saying you would go, is this funfetti they call that? Is that what it is, funfetti?
Yes.
All right. I would go with that one probably because it's chocolate frosting and there doesn't seem to be a lot of it. If there was one with only powdered sugar on it, I'd be all over that, but not many people like that kind of a cake. But anyway, birthday cake. And the way it looks right now is typically the way a lot of people cut their cake, right? You just take a slice out and you do it like that. Well, I was running across some things, and this came out in 1906 about how to properly cut a cake. Okay, and so let's take a look at some pictures here. So what you do is you take out, and we'll go back here. So what you do is you cut the middle slice. Okay, so you cut a piece out of the middle. All right, and after you do that, you put the 2 halves together. That way the cake is staying moist, because if you cut out a piece, you have 2 end pieces now that are going to start getting dried out.
Nice.
Okay, this way you cut out the middle, put the other 2 halves together, and it stays moist the whole time. Following me so far?
Yep.
All right. So then you can see now you turn it and you take out another slice that way, because otherwise you're going to get really small slices. I mean, you will eventually, but then you do it that way and you get another slice and you keep it together. So this brought me to, all right, a rectangular prism. So a rectangular prism, and you unfold it, you've got yourself a net. Okay, and I know that starting probably in about 3rd, 4th grade, a lot of students start working with solids and then being able to unfold them and see how they're made.
What we do now too.
And you can see them as a net, and then that way it's a little bit easier for the students to see what the areas of those different parts are. And so I figured we'd take one and do an example right there. So what we've got is the net that we have from the rectangular prism. If we have a 5 by 8, then we know that that area is going to be 40 square inches. We're going to have 2 of them, because if that was the front and the back, let's say, all right, then we have a top and a bottom, which was 3 by 8, and then we have the 2 ends, 3 by 5s, and simply by unfolding it, taking a look at the net, then you take all of the different areas and you have all 6, add them all up, and that's how you get the total area for a solid shape right there. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. In studio with us right now, we have Taylor and we have Caitlin. And how are you girls?
Good.
All right. Now, why don't you, how about Taylor? Why don't you let everybody know where you girls go to school and what grade you're in?
I go to Ronald Reagan and I am in 4th grade.
And both of you will go to Reagan and you're both in 4th grade, correct?
Yeah. Yes.
Now, how long have you been at Reagan?
Just this year.
Just this year?
Yeah.
And Caitlin, have you been at Reagan for longer?
I've been at Reagan since transitional kindergarten.
So you've been there for 5 years now, basically, because 4th grade is just about over. So since you've been there for a little bit longer, what is one thing you really like about your elementary school?
That it's always something that's new to do and it's always fun.
All right, and since you're new to school this year, what is one thing that's a little bit different from your other school?
Well, there's more equipment on the playground, like
And that's always a good thing, isn't it?
Yeah, because I love the playground.
Well, who doesn't like the playground, huh? Well, you know what? You girls are here to do a little bit of work, and we have a couple of moments, so what we're going to do is send you over to the board right now. So head on over to the board. Tracy's just going to draw a line right down the middle
Okay, hold on. Ready?
and give you guys each a little work area.
And you're Taylor?
Yeah.
And you are?
Caitlin.
With a K?
Yes.
There you go. Okay.
All right, now girls, I know that you've been working a little bit with fractions in 4th grade. All right, so what I'd like you to do is both of you write down the problem as I come up with it here, okay? So 2/7, 2/7, plus 4/7. And if you would go ahead and solve that problem for us. All right, so you both did that pretty quick. What I'd like you to do now is explain to Tracy a little bit and be ready to answer any questions that she has.
Okay, you start. So tell me kind of what this row represents.
It represents the numerator.
The numerator?
Yeah.
And you tell me what the bottom row represents.
The denominator.
The denominator. So how do you add? Like, what would be the process?
You add in the numerators, and then for the denominator, you just keep it the same.
So you don't add the denominator?
But that's only if the denominators for
the
both
same.
of the fractions are the same.
Got it. So if they're different, then what do we do?
You would
I
look to
actually don't
find
know.
the common denominator.
The
or
common denominator?
You would do a common numerator to figure it out another way.
Okay, well maybe we could try that.
Well, let's
then.
find out. All right, girls, here we go.
Hold
Let's
on,
start.
let me erase it. Oh, hold on, I gotta put your name up there. Okay, there, there we go.
All right, so here we go. Let's go 2/6, 2/6, plus 4/12.
So you heard what your sister said, right? So how do you do
We're not
that?
sisters.
Cousins?
No,
We're
Relatives?
best
Friends? Best friends. That's like sisters. I'm gonna call you sisters. Okay, so did you hear what your best friend said? How do you do it then?
You find the common denominators for the denominators
How do you do that?
by writing the common multiples for the denominators.
Okay, so show me. You want to do that too?
I think she already did it.
Oh, great. So I think we could probably stop, right? Was that a lot? Let's try down here and see what happens. Oh, did we find one?
Yes, 12.
And did you find one over there?
Yes.
12. 12. Okay, so I'm gonna erase this. We go around in the circle. Gone. Now try it. I know you wanted to do it. You can do it next. Okay, go ahead.
Can we erase all of this?
No, just the bottom part.
Okay.
Okay. Great. Okay. Now show me how to do it.
Oh.
Because we found out. It's okay. So here, now do it.
Oh.
So walk me through it. One of you guys. Show me what you're doing. Tell me what you're doing. Taylor, you want to start?
I'm kind of confused, but I think first you added the numerator, not the denominator, and then for
The denominator you put as 12 because the common denominator for 6 and 12 is 12.
Okay, and it's Kaylin, right? Can you tell me how to do it?
So you would change the denominator of 6 to 12 and then multiply 2 by 2, which was what changed the 6 to 12. And then you would add the 4 to the other 4 to get 8. And then since the two denominators are 12, you just leave it 12. And I just reduced it to 2/3.
So you simplified?
So you simplified.
Nice. You want to show me on your side?
Sure.
No, you're good. We're good. Go ahead. So when you simplify, how do you simplify?
You would divide it by the least common.
The least common? So
factor.
So did you start with 2 then?
Yeah.
Okay. So you end up with 2/3. Very nicely done. See, and we just taught you something new today. I know, that's weird, huh?
Yes, I have a black dot.
Oh, that's so odd, huh?
All right, nicely done, girls. Got that first problem done right there. 636-4357 is the phone number. We do have phone tutors available until 5:30. Time now to go out and about with Mary Lou.
So
We are live today at the Boys and Girls Club on Niles Street, and I am with Marshall Johnson and Sean Tobiasen. Can you kind of let everybody know what your position is?
Yes, I am an area program director with the Boys and Girls Club of Kern County.
And what does that entitle?
It entitles a lot, to be honest. I am a man of many hats. I do many different things. My primary focus is after-school programs and the clubhouses here in Bakersfield.
And how long have you been here at the Boys and Girls Club?
10 years. 25. 10 years, yes.
And Sean, can you tell everybody what your position is?
Yeah, so I do roughly what Marshall does as well, except for in addition to that, I also run the kitchen program. So Marshall oversees a lot of our after-school programs in different districts. I have Bakersfield City School District, and I help serve meals and oversee our nutrition program.
And how long have you been here?
I've been here 5 years on and off. 5 years, so not quite as long as him.
See, we come a lot to the Boys and Girls Clubs, both here and then the other one also at Stockdale, correct? Yeah. And we're normally with the students. And we're doing work with the students, but today we kind of want to get into more of the background. Exactly what does it take to put together all this?
It takes a lot of effort, and it takes a lot of passion, to be honest. I mean, our executive director, Zane Smith, one of his main phrases and philosophies is that club is not the facility, it's the people within the facility. And so when I say passion, it really takes the persons involved to really dedicate their lives and passion to providing this environment. So we've been in Bakersfield and Kern County for over 50 plus years now, and we're doing a lot of great work. So in the after school programs, we run all throughout the entire school, but when school's out, that's when we're in.
That's when you guys are busy.
Exactly. So not just the after school program, but it's also summertime, winter break, spring break. We're always in session for the kids here in Kern County.
So you've been here in this area for over 50 years, correct? So this was kind of the first location in this area. Yep. And then from there, where did you branch out to?
We branched out to many different areas. When we move out, we went to the Southwest. We've developed some programs in the Southwest. That's where you've been out there at our Stockdale Club, and we also have a Subaru Club right out there as well. Then we also are in Fraser, Lamont, Arvin. Those are those school districts out there, but we also have a clubhouse in Lamont. And so we're out there, but we also in all of Bakersfield City School District. We're partnering with Bakersfield City School District, Standard School District, Beardsley School District, DiGiorgio School District. And right now, our most recent one is we're assisting in Barstow. We're in partnership with Barstow. We're going out there to help develop capacity and programs out there as well.
So there's so much work involved and hundreds, thousands of kids. So kind of let's talk about the kitchen.
Yeah, so in what we do with the kids, we got a lot of concerns over where they're getting the next meals. So a couple years ago, there was a study came out in Kern County that basically said roughly 60% of students don't know where the next meal is coming from. So Boys and Girls Club basically took that on as a personal mission to say, what is it that we're going to do to supply these students with meals? So we've partnered up in Lamont, in Arvin, in Kern County to provide meals. And we started with roughly 200, and to this day, it's been about 2 years, and in 2 years now we're serving roughly 1,000 plus meals a day. So it's really taken off, and it just shows the demand for the community for this type of service.
So the kitchen's right behind us, right?
Yes.
Can we go over there real quick?
Absolutely.
So this is kind of where everything happens, right? All the prep, though. And you were saying earlier that you guys do all the prep here.
Yes.
And you send out?
Yeah, so we basically, as part of the grant and also part of the donors that we have, they supplied us with a couple vans that allow us to expand to the different communities we have in kind of the outskirts of Kern County. And so we have to make it here, and then we have special ways and honestly different equipment that helps it stay warm so that when we get it out to Arvin, Lamont, and the further distances that we serve. So it's really just helped us to be able to expand this. So roughly 1,000 meals a day come out of this kitchen and are moving on. And even this kitchen, we're looking to expand it. We were given a grant to also expand to our next door facility to create an even bigger kitchen so we could serve more students in the community.
What time do you guys roughly start then in the morning?
To prepare the meals, it starts at 8 a.m. So that's when we start cooking, and then the meals are going out about 12:30. And then serving between 1:30, depending on when schools are getting out.
Okay, so when we come back, you have some math.
Yes,
with
absolutely.
on how you guys figure out what you need to prepare, correct?
Yeah, we're going to find out kind of the averages of the students that we serve.
Okay, so we will be back with Sean and Marshall in just a little bit. So back to you at the studio.
All right, thanks for that, Mary Lou. A lot of exciting things going on at the Boys and Girls Club of Kern County. We do have phone tutors available until 5:30 right now in studio. We have Taylor and Caitlin, 4th grade students from Ronald Reagan Elementary School, ready to get the girls back to work. Let's go, girls, back to the board.
Go ahead and grab your pens.
So,
let's put a line right
we started
there.
you off kind of simple there with some fractions. So now we're just going to move it into the next step a little bit. So here's the problem. 4 over 7, 4/7 plus 2/3. So you can approach it as you did last time because you need to get yourself a common denominator, correct?
Yes.
All right.
So how would you start?
By finding the common denominators.
Okay, so are you going to do that or how you did down here?
Yeah.
Okay, go ahead. No, you're good. Go ahead and try it. You going to go ahead? Okay. So now what are you doing then?
Writing the common multiples.
Common multiples, that's right. It's been a long time since I taught 4th grade.
You taught 4th grade?
Long time ago. Long time ago.
I can hear you. You got you.
Okay. Oh, keep going. We're not there yet, are we? I thought we were.
Oh, that's cool.
3, 6, 9. Hey, can I add one real quick?
Yeah.
3, 6. Oh. Okay. Okay. So did we find it?
Yes.
Great.
Not yet.
No, not yet. Okay.
There.
Perfect.
And I think
So now what do we do?
we add the fractions, but change this one into 21.
Okay, so show me how you do it.
Can we use these?
Sure. Go ahead. You do your little magic thing that you do. Ready?
It's gonna be gigantic.
Okay, do it in littles. Okay, ready? Just do it in littles.
Got it.
And okay, now this doesn't want to work today, huh? Here, let's do this. I'm gonna try it for you.
Ooh.
There we go.
I think it likes you better.
I think so, huh? Maybe it's just moody today. There. Okay. So then we have 21, so let's see. Nice.
No.
Yeah, see, I think that's why. Did you already get an answer?
I think so.
Okay. Okay, so you guys got different answers. So I can see what you did. Let me show you, okay? So when I do problems, I do them up and down. So I change it to 4/7 plus 2/3. And the reason why I do that is because see how it got all mixed up? So I'm gonna do it like this, and I want you to see if you found your mistake. Okay, now I want you to retry it. That's okay. So did you see? Okay, now you forgot to do it to the top too. So now add the 2 numbers, and I think you'll get the same number she got.
I'm not sure if she can reduce it.
Oh, let's see.
Reduce what?
No, just keep going. Now, good. We have to write 21 there. Okay, now let's see what you got. And you got 1 and 5/21? Okay. Okay, so now how do you do that? So here's what I say to my kids. 26 goes into bye-bye. I always say you have to live on the outside of the house. So 21 goes on the outside of the house and 26 goes on the inside.
It's a division.
It's a division, correct, because it's a fraction.
So I
You're
simplify
right.
it?
So you're going to simplify it. She's going to show you right now. Because you have to make it a, what kind of fraction? Because it's improper right now. What are you going to make?
Mixed.
Correct.
So that's 1/5? Oh.
And 20, correct.
Oh.
See? Very nicely done. Okay.
All right, girls, how you feeling with that?
Good.
Feeling pretty good?
Yeah.
Let's move it up just a little bit more now.
Okay.
All right, so let's erase that.
Put the line down.
So we're through adding. All right. Now we're going to start, and I'll keep it small for you right now.
Okay.
All right. 3/5
Oh,
times 4/6.
Have you multiplied fractions before?
Yes.
All
They're not the one that has different denominators.
Oh, it's easy. How do you multiply if they had the same denominators?
You don't even bother to look at it.
So you don't have to bother to look at it now either. You can do the same thing.
Oh. Do I keep it for the 5 or 6?
So you same thing, you're just multiplying straight across.
Oh.
Nicely done.
And they both have the correct answer.
Yes, very nice.
But
She simplified.
can we simplify on one?
So keep simplifying on yours. So, yeah. Very nice. And you know how to cross reduce. Very nicely done.
All right,
We
go
got
ahead and
it.
erase that, girls. That
Ready?
seemed a little bit right on track, girls.
You're like, oh,
Okay, put a line down the middle. We're doing one
Can
more.
I do it? Yeah.
Now we'll do one more.
Okay, ready?
All right, so Caitlin, give me a number.
6.
All right, so 6 is the numerator on the first fraction. Over, Taylor, what would you like the numerator to be? Or the denominator, I mean.
5.
All right, so 6/5
Oh, let's see.
times, and we're going to get everybody involved in this one. So Tracy, the numerator on the next one.
2. I picked it easy for you guys.
Thanks.
All right, well, we're not going to leave it easy, so let's make that a 7 underneath.
Okay.
I picked it already.
Okay, so now what do we do?
We find a...
Nope.
Oh, wait, we just multiply it.
Yes, it's the best ever.
And then we simplify it?
I don't know, can you?
No. Nope.
Do you know how you can tell whether or not you can? So first of all, this is a even number. And
this is an odd number.
Correct. So kind of hard to do that, huh?
Yeah.
Right? So we didn't even have to do anything. You want to go ahead and do yours? We have to have, all right. Do you have to do it that way?
No.
You're just doing it because you want to?
I just do it
Okay,
because
go
my mom
ahead.
taught me
That's
that
good.
way.
No, go ahead. That's great. She's doing it the hard way.
We're doing the cross multiplication at the same time.
So the reason why she's probably doing that, and what we teach our kids, is because when you get into the habit of making the denominators the same, then adding and subtracting are easier because you never forget. So that's probably something maybe her teacher taught her.
Okay.
Our kids in 7th grade take it easy, so they're like trying to find every shortcut they can. However, that's probably what her teacher has taught her, which is a good habit to get into. Very nice. Then her parents taught her. Very nice. That's a very big number.
She's gonna simplify that. Oh wait, sure.
So you could have simplified the 5 and the 35 too, right? Back down to where you were? Yeah. I bet it's going to equal 12 over 35.
It has to.
I know, right?
Now, the 42 and 35, because I saw you simplify earlier. So is there anything that you could simplify 42 and 35 with?
These two.
Is there a factor that goes into 35 and 42?
Oh yeah, 7. Divide by 7.
Stop. I know. We're still going to get to 12 over 35 though.
I can hear you.
I can hear her too. So it would be 30 over 35.
And you simplify that.
Oh, we messed up somewhere, huh?
6 over 7.
Oh, we messed up
Did
somewhere.
I get it right?
I don't know, did we?
Well, what she was trying to do is get a common denominator
Right.
when you're adding and subtracting, but you can't do that when you're multiplying.
Because it doesn't work out the same.
So you see how that happened?
So we were letting you go so you could tell that you just multiply straight across. If you try to find the common denominator,
It'll be a lot harder.
it actually doesn't work out right.
Oh.
Right? You helped us prove that. Thank you very much. That was awesome.
Now, there was one thing that you girls were doing, so go ahead and erase the board because you were talking about how when you had 12 over 30, so put 12 over 35 again. And you were talking about how that couldn't be simplified because one was even and one was odd, correct?
Yes.
All right, so now what I'd like you girls to do is I'd like you to write next to that 12 over 15. Now, it's both an even and odd number, but can you simplify that?
You can.
Yes.
Yeah.
So simplify 12 over 15.
So it doesn't matter what the denominator or the ending number is, does it? So it can be an even and odd, huh? See, it can be an even and an odd number.
There you go, nicely done. I just wanted you girls to see that just because it's even and odd doesn't mean it can never be simplified.
See?
So 12 over 35 couldn't be, but then when we went 12 over 15, that can be, right? So did you girls see that?
Yeah.
So it doesn't
All
matter
right, nicely done. You know what? For doing some great work on fractions thus far, we will be sending you girls to the Bakersfield Condors, one of the hockey games. So the season is still going strong here in Bakersfield. We do have phone tutors available until 5:30. We'll do some more with the girls and be back at the Boys and Girls Club right after this. Today we're at Sunset Middle School, home of the Rockets, and today we're here to
Do the math! Yay!
Well, today we're at Sunset Middle School, and I've got 6th grade student Monse with us. How are you today?
Good.
You ready? Let's go. We're going to take a look at some numbers, and we're going to determine if they are prime or composite. Okay? So a prime number, once again, what can you tell me about prime numbers?
I can only go with ones.
Only one and the number itself will go into it. Okay? So if I had the number 7, all right, the factors of 7, numbers that will go into 7, are 1 and 7. 1 and the number itself, right? There's nothing else that can go into 7 evenly. All right? So what about 10? What can go into 10?
1, 2, 5, and 10.
Right. Anything else? Nope, that's it, right? And we always want to make sure that they match up, right? Because we've got 1 times 10 and 2 times 5. 5 times 2, we still have the same numbers, right? So what I'd like you to do is select a number between 1 and 100.
20.
20, all right, go ahead and write 20 on the board. Now, do you think that is prime or composite?
Composite.
Why?
Because more numbers could go into it.
More numbers can go into it? More than what?
Just one.
More than just one? So why don't you go ahead and write down the factors, the numbers that go into 20 for me. Okay, I'll grab this eraser next time we need it there. All right, so you've got a lot of numbers there. So okay, so we know that 1 and the number itself will always go into any number, right? How do you know 2 went into that so quick?
Because 10 times 2 is 20.
10 times 2 is 20. Plus it's an even number, you know 2 will go into it, right? Now what about 4? Because why not 3?
Because 3 is an odd number.
3 is an odd number, but 5 is an odd number too, right? But why doesn't 3 work then?
Because if you multiply 4 times 3 is not 20.
Correct. And 3, if we go 20 divided by 3, we won't get an even whole number. Okay, so it won't work out to be a whole number. So we've got 4 times 5 and then 5 times 4. And the 2 and the 10 match up. So you pick the number, now I will. All right. Let's go with 33. You think that's prime or composite?
Composite.
Composite? That one took a little bit. Why do you think it's composite?
Because 11 times 3 is 33.
There you go. So why don't you go ahead and write down the factors of 33. Good. And there are no other factors, so you did pretty well on that, knowing that it was 3 times 11. Okay? Can you think of a number that will have more factors, more numbers to go into it than 20? Can you think of any number that might have more, like a longer list than 20 has? Because 20's got 1, 2, 3, 4, 5, 6 numbers in it. Can you think of anything that has more than 6? What numbers are you thinking of right now?
Maybe 100.
Maybe 100. Let's try it. Let's try 100. All right, why don't you go ahead and start listing factors for that? There you go. So we matched them up, right? So we've got 1 and 100, 2 and 50, 4 and 25. So that gives us 6. Think about 100. Okay, it's an even number, so we know 2 goes into it. But if a number ends in 0, what else will go into it?
20. Maybe.
Think about this.
10.
Right? So what else goes into it besides 2?
10.
10 can go into it too, right? So we can put 10, but that's 10 times 10. And what else? There's another number that will go into it because it ends in a 0.
5.
Right? So think about it. 5 will go into 100. If you count by 5s, can you get to 100? How many times is that going to be?
50. No, 20.
There you go. So why don't you go ahead, because we've got 5, and then the next one is going to be 20. So now how many factors do we have?
1, 2, 3, 9.
There you go. So we beat the 6. Won't say? Nice work. And once again, a big thanks to all of the staff and students. Always a fun time to go out and visit some different schools and work with some different students. We do have phone tutors available until 5:30. We've got a phone call coming up. We'll make the girls do some more work, but first we're going to go out, do a little bit of math with Mary Lou at the Boys and Girls Club.
We are back live at the Boys and Girls Club on Niles Street, and I am with Sean Tobiasen, the Area Project Director. Program Director.
So close, so close.
Okay, now we had left and we were talking about the kitchen, and you were saying that you received a new grant.
Yes.
So you guys are in some...
Yeah, we're doing some construction. So right now we're still kind of working out the bidding process, but we do have whole expansion on our kitchen. So, and what we're doing in the community, we've seen a lot more demand for a lot more meals to be served, but we're kind of limited by our kitchen size. So we got the grant to basically almost double the size of our kitchen. We're looking to get a walk-in fridge, new equipment, updated equipment, more room, so it's going to give us the opportunity to serve a lot more students in the community.
So do you have a time frame about when they'll be completed?
Yeah, we're hoping that's going to be done kind of by the end of the summer so that we can be ready for the school year when it kicks off.
Okay, so there is math involved with the kitchen.
Absolutely.
Because there's so many kids that you need to feed. Now, the meals, is that breakfast and lunch, or is it just lunch?
Depending on the season. So during the summer season, we basically look at the demand of the students. So the students, obviously priority meal is going to be a breakfast and a supper. And so we're able to provide that during the breaks, but during the school year, they usually get that from the school. So school year, we offer a snack and a supper. And during breaks, when they're with us the whole day, we give them a breakfast and a supper in that time.
Okay, so you have a problem for us, right?
Yes, we do. So part of what we try to do is we can't really waste meals, right? We're a nonprofit, so we have to be really kind of close on what we're expecting. And so the first thing we have to do is come up with trends. So you're going to see June 2015 through June 2018. And so one thing we want to look at is our average daily meals served. And that we try to trend based on the month. So June is a hot month. So sometimes we lose meals because a lot of kids don't want to be out in the heat. Sometimes, obviously just summertime, we're at 108 degrees, so some kids like to stay at home in the AC. So we look at the trends per month and we break it down per day. So you'll see June 2015, let's say we average 180 meals for the month of June every single day. In June 2016, we averaged 200. In June 2017, we averaged 220. And so right now I'm in the process is we're trying to look at how many meals we could expect to serve every day in June of 2018. So we look at the pattern and the trend that we've set forth. So let's say in Lamont every day we average 180, in 2016 200, in 2017 it's 220. We can project based on the pattern that we're probably going to serve 240 because it's gone up 20 every single year. So 180 to 200 to 220 to 240. So that's part of what we do is projecting. The other thing that we have to do every single week is we want to analyze how much we have to order for that next coming week. And so what we do there is we're taking basically our average daily served, but not per site. We're looking at overall as a program whole. So let's say Monday we served 1,100 meals, Tuesday we served 900, Wednesday we served 1,050, Thursday we served 950, and Friday we served 1,000. So what we're looking at, one more zero. Is that how 1,000 works? I forgot. So when we add all that together to find the average, we have to take every single day and add it together. Based on my genius skills at math, that looks to me like we're looking at 5,000 for our total meals served. If Mike back there can correct me, so be it, but that's looking like 5,000 to me. So now to find the average, we have to take our total, which was 5 days served. So when we do that, we're going to get the 1 here, zeros across. My handwriting is that of a 3rd grader. I apologize, but 3rd graders, you can read it. So we're looking at that we serve 1,000 meals every single day. So now when we're projecting for that next week, we can look and say, so if we're serving 1,000 meals a day, we know how many we should order for those meals accordingly.
Do you guys try to get as close as possible so you have the least amount of waste as possible?
Yeah, basically, because obviously as a nonprofit, funds can sometimes be limited. And so if we're projecting, if we did this math wrong, and let's say we thought we were going to serve 2,000 meals every day for the next week, a mistake like that in math, a mistake like that can set us back, honestly, months if we're not projecting correctly because we have to order so far in advance. So if we're not doing the averages correctly and we come up with a poor number there and we order that inventory, it can really mess us up and really cause us a lot of waste.
Do you guys guys order by month, or is it more of a projection with a few months?
We order week to week, but we still have to give our supplier basically a month in advance to kind of have in inventory how many we're expecting for the next month. So every week we do a new shipment, but we're basically trying to project for them and show them a month total, so that way they have it on supply for us.
Okay, well, thank you so much. And we have a lot more going on here at the Boys and Girls Club. So, Sean, I'm going to have you send us back to the studio.
Oh, hi, Mike. Back to you in the studio.
Yes.
All right, nicely done with everybody out there at the Boys and Girls Club. We do have phone tutors available until 5:30. As a matter of fact, we're going to go to the phones right now. Jasden, how are you this afternoon? Hello, Jasden.
Hi.
And are you in 7th grade?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Your credit card has a balance of $1,000. The minimum payment is $25 a month. How long will it take you to pay off your debt?
Hi, Jasden. It's Miss Underwood. How are you?
Good.
So, if I remember the homework right, then you already owe $1,000 to the bank. Is that correct?
Yes.
Okay, so I'm going to do this 2 ways. I'm going to do it the really, really long way, just to prove a point, but not all the way through it. But then you can tell me how to do this. So we automatically start off negative, correct?
Yes.
How much do you pay every month?
You pay $25 a month.
Okay, so we're going to add 25, which means that we're going to pay it down to $975. So this is like the really long way. Let's just see. I'm only going to do it a couple of times. But we still owe $975. We pay another month, and we now owe $950. So if I continued, we would get down to a zero balance, correct?
Yes.
But what's an easier way to do this? Do you know how to do this problem by doing it the easier way? If I'm like subtracting money off of something, what's another operation I could do?
Subtracting?
So if I'm subtracting, what's another operation that I could do?
Adding?
So if I add, but tell me another one. So if I have $1,000 and I'm paying on it $25 a month, what's another way I could write this besides subtracting it until I get down to zero?
Dividing?
Dividing. So subtraction and dividing are kind of similar, correct?
Yes.
Okay, so why don't you help me on this one? If I am paying $25 a month and I owe $1,000, 25 goes into $100 how many times?
50.
So if I have 50, would that be, let's try it, because I think we might be off. 5 times 5 is 25, 5, 10, 11, 12. I think we're over, because it comes up to $125. So how many times, not 5, what's another number it could go into? Less than 5.
Less than 5.
Let me put it a different way. If I have 25 cents, how many quarters can I make for $1?
4.
So it's going to go in 4 times for 100. 4 times 25 is going to be 100. We bring down the 0, and then we pull the 0 up. So it's going to be in your answers 40 months, which is like 3 years and 4 months to pay this credit card off. Very nicely done. So your answer you're going to put down on your homework is 40 months.
But you're not through yet. Because it is March of 2018. Jasden, what I'd like you to do is figure out what 40 months from now is if you actually had to do this. You ready to do that?
Yeah.
All right. Tracy's here to help you out.
Okay, so let's think about this. If we're in March, so what month are we in for the year? Like the first month, the 6th month, how many months are we into the year?
3.
So, okay, so we're going to start with March, and we're 3 months already into the year. How many months, if we're at 40 months, how would we figure out when we're paying this off? So if we go one full year, March of 2018 to March of 2019, how many months did we pay on it? If we started in March of 2018 and we go to March of 2019, how many months did we pay on it? So we're going to count. Are you ready? So we have March is 1, April, May, June, July, August, September, October, November, December, January, February. February would be 12.
13.
13 months. Okay. So 13. So let's continue. If you go all the way to March again, now how many months? Because it's not going to be 13. Because we've already included that March. So now we're going to be April, May, June, July, August, September, October, November, December, January, February, March. How many months do we now pay on it?
14.
It's actually less. I think it's 12.
12.
So we're going to 12. We're trying to get to 40, right?
Yeah.
So now we're going to do March again. March 2021. Now we already know it's going to be 12. How much do we have? We have 13. CB 2, 3, 4, 5, 6, 7. We have 37 months. We only need 3 more months. So what month will we pay the credit card off in?
And
I'll give you a clue. We're not going to school. Well, we do like 3 days into that month, but that's it.
June.
June. So we have until June 2021 will be our last payment. Last payment to that credit card. And by the way, that does not include interest. That's only paying off the $1,000. So much money.
Well, I thought you were going to let me go with this and add some interest on there. I was going to make it a nice number, you know, like
Right.
6.25% or something. But we'll leave it at that.
no.
Daz, nicely done. And for that great work right there, we're going to send you to any athletic event of your choice at CSUB, courtesy of CSU Bakersfield Athletics. So thank you for that call right there. Hey, we do have phone tutors available until 5:30. The girls are well rested. So let's take a look, girls, and go back to what you guys are going to do. You ready?
There?
Yeah.
Here we go. Over to the board.
There you go. Okay, pick your pins up.
All right. So, Taylor, you're going to label what looks like an X right there. All right. So, what I want you to do is on one of the lines, I want you to put a dot at each end of the line. Not at the very end, but close to the end.
Perfect.
And do another one. All right. And select 2 letters to put with those points. T and L or T and C?
T and L.
T and L. All right. So go ahead and do the same thing to the other line. All right. Caitlin, on what looks like an equal sign, I would like you to do the same thing. Put 2 points and label them on both of those lines. Well, let's do different letters. Oh, you could. I just didn't want 2 Ks up there on the same. That's all.
That's A, B, C, D work, huh? No. Just put it, no, A, B, how about X and Y?
I guess you took their place.
See, you're trying to be different, huh? Okay.
All right, what I'd like you to do before we move on to the last one is where you put those points at the end, I need you to extend the line a little bit because now we have rays up there.
So in order to do that, both your pencils have to be put down. Okay, now push it like we showed you. Okay, ready? Nope. There you go. Now drag them out. Or you could, ooh, that's better. Let's do that, okay? No, you're okay. Let's drag the points in
There
a
you go.
little
Just
bit.
move the point in, then you'll be fine.
There you go. Okay, can you do that on the other 2? I do, huh? Perfect. Now here we go.
All right. Tracy, go ahead and label up that last figure that we have there.
Okay. Ready? There you go. We're going to label it up. I'm changing my color to blue. I'm going to do L. Oh, it didn't change my color, did it? L-O-V-E. Right? We'll do that.
Love that.
It's because I...
And what I need you to do is put little arrows at the end of all of those lines.
Okay, I can do that. I'm going to trade you pins, though.
Yes, I want to.
Okay, so we're going to put little arrows.
For now.
Just like that.
Oh, on every single one.
On every one. Over there, too.
And we have 3 different things up there, we'll call them for now.
Okay.
And what I'd like you to do is all 3 of you kind of discuss what you see up there, what you know about those, what you know already, and what Tracy can kind of help you out with.
So what do you see? What do you notice? Tell me.
Oh, you know what we need to do in the first one that Taylor was labeling, right in the middle, right where they crisscross? Let's go ahead and put a point there.
Right there in the middle.
And label that as well.
What letter do you want to label it?
It's an A, not very
And I'll give you 30 seconds per figure.
Okay, ready? What do you see? What do you notice? Go.
They're both intersecting and they're both straight lines and they're both going on and on. Yeah, they're going on.
Because the arrows?
Yeah.
Okay, so you go on that one.
I noticed that they're both parallel, and as I said before, they're both going on and on because they have arrows.
Okay, and then both of you tell me what you see in that one.
They're both intersecting, and they're both perpendicular. And
nice.
they go on forever because there's arrows on each line.
Perfect.
Now you said they're intersecting and they're perpendicular, so what's the difference between those two now? Because you said the first one was intersecting but not perpendicular.
Perpendicular means that you can make a square with the corners.
Or a 90...
Or a 90 degrees and that's obtuse angle.
Nice.
Or right angle.
Right angle.
Yeah.
And how many degrees are in a right angle?
90.
90 degrees. And what about an obtuse angle?
Over 90.
Such
So,
as? What's the highest it could be?
100? 360.
How much is a flat line?
130.
100 and what?
180.
Well, you could have an obtuse angle large, right?
So it could be
But
larger than 180.
what's the largest it could be? Because I thought you said 360, right? If it was 360, what would that be? 360 degrees are in a
circle.
So would that be an obtuse angle, though?
No.
So what would the highest number of degrees be for an obtuse angle? If you wanted to make it really, 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 really big.
A bigger circle? No. 359.
Or if you made it so it's obtuse, right? And we're going to talk about this in a minute, all right? So I want you girls to think about that for just a moment. Right now we're going to go back, visit with Mary Lou and the boys at the Boys and Girls Club.
We are back live at the Boys and Girls Club on Niles Street, and I am with Marshall Johnson and Sean Tobiason, the area program directors.
Yes, well done.
Can you tell us where we are right now?
We are in what we call the backyard, but it's Kevin Harvick Foundation Park, and this is one of our pride and joys because for the longest time, this backyard was an empty lot. It's like you go outside of Bakersfield and you just see this open dirt lot areas, and that's what it was. There was absolutely nothing here. It was collecting trash, debris, everything blown in off the street, and it was all piling up against our wall. But thanks to a Wells Fargo Urban Lift grant and a special thanks to Kevin Harvick and the Cal Ripken Senior Foundation, we were able to come back and turn this into an amazing sports field for our children here.
I know we usually kick off our season here all the time. And when we first started coming out here, yes, it was just grass. Mm-hmm. And then the next year we came out, the turf was out here. Yep. And then I've noticed little things added. Is there anything more that you guys are going to be adding to this? Because it's pretty amazing out here.
Well, every year we're always looking to grow, and I think that's the beauty of us in Kern County, is because we're one of the biggest counties in California, and the kids, we still haven't reached all the children here in Kern County. So this, I can say for sure, this is not the end. There's going to be more things that is happening. We do different things. We're actually starting new soccer leagues, and so they're using this field as a soccer league. The first soccer league was last year, but we're going to continue doing that, and so it's definitely going to continue and grow.
Now, how does the program work with kids and using this out here? Do you guys have it all kind of organized where a certain time, okay, everybody's out here, or a group is out here?
Yeah, we have a program director who develops program structure and schedules for whatever the activities planned for the day. We'd love to have all the kids throughout all the day, to have them here in our facility. It'd be great. But of course, school's going on, and so when school gets out, we get everybody roughly around 3:30, sit them down, feed them. They have their homework time, and then we get them for roughly about an hour and a half before parents start picking them up. So within that hour and a half throughout the week, we develop schedules so the kids can come out and use the facilities in any way that they desire, based on our program director's structure.
And you guys also have a beautiful gym in there.
Yes, we do.
That has been redone as well. So how can a community member get involved with the Boys and Girls Club?
We're always looking for communities, partnerships. I mean, we partner with a lot of different vendors and Rotary clubs. And we're always looking for more people to come in and donate and even spend their time. It doesn't have to be monetary. It can be their time, because that's the most valuable thing anybody has is coming in, spending time with the kids, and just being a part of the club. But how they can is they come down to our club. They can visit our website, bgclubs@kerncounty.org, find out more information on what location is best suited for them. But they can always come down to our main facility at 801 Niles Street and talk to our front desk staff. We can get them set up with the volunteer orientation. And from there, we can point them in the right direction, get them involved with all homework activities if they want to focus on tutoring or special academic sense from that, or sports leagues, or just hanging out with our children, because we want everybody to be a part of us. And and on top of that, we're always hiring. We're hiring for more and more staff to come in and help us with our after school programs with all of our district partners.
There's just so much involved, and you guys, like you said, keyword is growing, and you are growing all the time. Obviously, going now through to Barstow and all that. Is there anything else that you can think of to help with fundraising or anything like that?
I think the main principle is a lot of people still don't know we're here, and really getting the word out. So if you do know about the Boys and Girls Club, if you do know about what we do, and especially after what Sean said about feeding the children in Kern County, and it goes along with our mission statement to enable all young people, especially those who need us most, to reach their full potential as productive, caring, responsible citizens. Yeah, I memorized that.
That's very good. And you know what? I'm going to end it there, because that was so wonderful. Thank you so much for taking your time today and showing us around. It's absolutely wonderful. Again, please visit their website if you are interested in helping out in any way you can. And that's it from the Boys and Girls Club on Niles Street. We're going to send it back to you at the studio.
All right, thanks for that, Mary Lou. A lot of times we have opportunities to work with the students at the Boys and Girls Club. Nice to work with the staff right there, and some more behind the scenes things. Did you girls have fun?
Yes.
You know what? We need to say hello to some very special people. So 1, 2, 3.
Hello, Washington, D.C.
That's right. There are members actually of the Boys and Girls Club in Washington, D.C. for a conference right now, and they are watching you guys live because they knew the Boys and Girls Club were going to be on today. Wow. You are nationwide and worldwide. Hey, you know what? We do have phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.